Welcome there. This is physics under uniform motion. Let's look at this question from WAEC 1996. Okay, the question goes: the diagram below illustrates the velocity time graph of the motion of a body. Calculate the total distance covered by the body. So this is the diagram they're talking about. This is the diagram that represents the motion, the uniform motion of a body. So we are to calculate the distance, the total distance covered by the body. So first, looking at this graph, what kind of graph is this? This is a graph of velocity against what? Time. Velocity time graph. And then you know that velocity equals to displacement or distance divided by time. So that distance or displacement can be written as velocity times what? Time. Velocity times time. So what does this mean? It means that take for instance, if you take the square portion of this graph here, the square portion, if you do length times breadth, your length times breadth will be velocity times time, which will give you distance. So what am I driving at? What I'm trying to say is that the distance covered by the body is represented by the area of the shape formed by the graph. So the area under this graph will give you the total distance covered by the body. So now here is the task. How do we determine the area of this shape? This shape is not a shape that is really known to us. But however, since it's not a shape that we really know that we can say, okay, this is the area of this is how to calculate the area of this shape. What we'll now do is we will divide the shape or segment it into the shapes that we know. Before then, let me label the shape. Here is already 0. At this point here, that is 10. At this point here, that is 10, I will label it A. And then here, this point here, B. Sorry, B. And here, C. Here, D. And then here, E. And here, F. So I'm done labeling my graph. So now I'm going to segment this graph, or should I say divide it into various shapes, and then find the sum of the area of each of the shape. So let's dive into action. So now, distance covered, total distance. Total distance equals to what? Area under the graph. Area under the graph. So now, how do we get this area? So the first shape you can see here, OABF. Do you see that shape? OABF. This is a trapezium. Trapezium is a shape that has two of its sides parallel. So you see OA is parallel to what? BF. So why this side is not? So this is a trapezium. OABF. So equals to the distance now equals to area of what? Trapezium. Area of OABF plus the next area here. The next area here we see looks like a square. The next area here is BCEF. Area BCEF plus. And the last shape we have here is a triangle. So area of a triangle. So this is CDE. Area of what? CDEC. CDEC. WAEC. So this is it. So yeah, there are three shapes in this one shape now. So we're going to find the area of each of these shapes. So the first one here is a trapezium, OABF. So let's get things done. Okay, let me take that up. So now our distance, let me represent it with letter D, or total distance will be area of a trapezium. Area of a trapezium is a half of the base. Half of the base. So what is the base here? Um, okay, a half. Area of a trapezium is a half times the summation of the parallel sides. The parallel side here is OA and BF. OA and BF. So we open that up. OA plus what? BF. We close. Then times height. Times height. What is the height of this? These are the two parallel sides. OA and BF are the parallel sides of this trapezium. So the height will be, the distance on the T axis. So the height will be from O to F. From O to F. So what is the distance from O to F? From O to F is 5. Or that would represent our height OF. Okay, let me just write OF here first. OF plus, here is area of a square there. Which square are we talking? Area of that. Okay, plus area of a square. Let me still repeat it. B C, excuse me, that will be BC times what? CE. That's how to get area of a square or a rectangle. BC times what? CD. That's length times breadth, or breadth times length. BC times CE. BC times what? CE. Plus area of a triangle is a half of the base. Okay, a half of the base. So which of these is the base? The base could either be CE or ED, or this place. So a half of CE times what? EDE. A half of CE, a half of CE times DE. Okay, so this is the formula for area of a triangle. The first one for area of a trapezium, area of a rectangle or square. So let's plug in our parameters. This is 1/2. You open OA. What value represents OA? The OA, that's from this 0 point to this point, is 10. From 0 here to the point is 10. So OA is 10. OA is 10 plus BF. BF. BF from here to here, if you can see, you trace it down, it is 20. From BF, that's from down here to that top, if you trace it down, it's what? The length of this height is what? Is 20. So we write there plus 20. And then OF, which is the height, OF, that's from here to here, from O to F, that's 5. That is 5. Okay. plus BC times CE. BC times CE. Let's extract that. BC from here to here, you see from here to here, between here and here is 5 to 10. So the distance from here to here will be 10 minus 5, which will be 5. So distance from here to here is 5. Hmm? From here to here is what it's 10, but we are looking for from here to here. So it will be this 10 minus this side will give you from here to here. So 10 minus 5 is 5. And then from here to here is 20. So that will be 5 times 20. So here will be 5 times 20 plus I have CE times DE. Let's extract that. CE times DE. Our CE, that's from here to here, is 20. Our DE from here to here is 5. I hope you know how we got 5. 15 minus 10. We want distance from here to here, so it's 15 minus 10 will give you what? 5. While from here to here, C to E is what? 20. That's with respect to the V axis. So this will be 20 times 5. 20 times 5. So I have times 20 times 5. So let's do our calculation now. So this is 1 over 2. 20 plus that is 30 times 5 plus 25 times 20 is 100 plus these 2 here will cancel this 20 10 times. So 10 times 5 is 50. Times 5 is 50. So 2 cancel itself, 1 cancel 30. 15 times 5 is 75 plus 100 plus 50. Are we there? Yes, we are. So if you finish that up, 50 plus 100 is 150 plus this, that will be 225. 225 meters. So the total distance covered by that body is what? 225 meters. So this is how to do this. You can repeat the video several times to understand it better. Thank you.